Okay, so what do you want to discuss?
The interest rate.
Interest rate? Okay. So what is the problem saying? You know what, you know what, I don't have it. I can probably pull it up real quick so everyone can see it. Oh wait, this is the one I handed out, right?
Yes.
You know what, I don't have it on this computer. And I didn't email it, so can I just borrow yours? See, I might have a copy here. Oh, wait. Oh, I do have a copy. Here you go. Anyone need a copy? They're $3. No? I think that's it. Okay, so number 14. $2,500 is put into a simple interest account for 3 years at an interest rate of 2.625. Part A, how much will be in the account if the interest compounded weekly? How much interest was earned? All right, so which formula are we going to use for part A? The ugly one. Pardon? Yep, it's not the shampoo formula. This is going to be this one. And the reason we're using this, because it's compounded weekly. And the only time you use the shampoo formula is when it's compounded continuously. So we're going to use this, and we are told that the amount that we're starting with is $2,500, right? And then 1 plus the interest rate, which is 2.625. We need to convert that to a decimal. And then divide that by n, and then raise that to the n times t. So what is n here? We're compounded, what? Weekly? So how many weeks are there in a year?
I said 48.
52.
Oh,
There's 52 weeks in the year. So you'll have to know that, all right, if you're going to use this formula. And then raise to the n times t. So 52 weeks. And then what was the time we were leaving this in here for? 3 years? Sometimes people think because it's 3 years, they take 52 and multiply it times 3, thinking that's how many weeks you have. But you don't. This is always the number of compoundings per year. So it's 52 here, and then the 3 goes here. All right? So now we need our calculators, and we're going to crank this out. So always start within these parentheses. Work this out first. So let's make sure you can get that on your calculator. And I said to use as many decimals as your calculator will give you if you want to be accurate. Okay, so I did this number divided by 52, and then I added 1, and this is what I got. And then I did 52 times 3 and got 156. Now what's next?
you multiply the 1 to 156?
You raise it to the power, yes. So you take this and raise it to this power. Do not do the 2,500 yet. That's the last step. So now this can be 2,500 times, let's go ahead and see what number we get when we take 1.000504,808 and raise it to the 156. We should get 1.081912359. Then I take that number and multiply it times 2,500. 2704.78. So that's, yes. Use the caret key. So that key right there, a little up arrow. So put 1.000504808. 808. And then hit that arrow key and put 156. Hit enter, and you should get this number. And then you multiply that times 2,500. So we've answered one of the questions for part A. It asks how much will be there, right? How much will be in the account? That's how much will be there. How much interest was earned? So how much did we start with? So if you subtract 2,500 from this, you'll answer the second part of this, which is 204.78. What's wrong?
Oh, I mean, my answer was right, but instead of, I put 48 instead of
52, okay, yeah.
So how do you do the power of 156? Or is it that yx?
Yes.
Okay,
Yes.
So I type in that, and then I type in yx.
Yeah, type this in.
So we started on 2,500, so we minus, subtract that 2,500 from 27.
Yes?
No.
No?
I'm gonna figure out.
Let me see it.
I just keep getting the same number.
So you get that interest.
So 1.000504808 raised to the 156.
Oh, you know what? Yeah, I am getting it. I'm
Yeah,
sorry. I'm looking
yeah.
at 27.
Yeah,
My bad.
that's it.
I'm sorry about that.
No, it's all right. Okay, this good? Yes?
Are you dollar now?
Yeah, this is dollars. Yeah, these are dollars. So what's the difference between this one and part B? It's compounded monthly, right, in part B? So that changes the 52 to 12, and this 52 to 12. And then you redo it the same way. Do you want me to work through that one, or are you okay? Yes? Okay. So for that, for part B, you're going to have 2,500, 1 plus 0.02625 divided by 12 raised to the 12 times 3. So this is going to be 2,500.
You remember when you got that
Dot and
2 So that's the interest you just subtract. Oh, from that? Yeah, okay. Yeah, to find it.
So I'm getting 1.0021875 raised to the 36. So I get 2,500, 1.081840754. So I get 270460. Slightly different answer? By a few cents, right? And then that's the answer to the first part, and then the second part is how much interest did you earn, so it's 204.60. Same thing, subtract 2,500 from that. Now for part C, we change our formula, right? Because it's compounded continuously. So for continuous compounding, we use this formula. So it's 2,500 e to the 0.2625 times t, which is 3. Zero. 0.2625. So you should get 2,500 and then 1.081933805. $2704.83. So again, just a few cents. Does that answer your question there? Any other questions on that one? Okay, what else?
Can you do number 11?
Number 11, sketching. Oh, can I erase that? Yes. I'm doing e raised to the 0.02625 times 3. So on your calculator, you got to bring up the E button, or the E. You know where that is? So E is above the ln. So you're going to hit the clear. Nope, clear. Hit the green button first. Then the ln. See above the ln it says e to the x? So there, and now put 0.02625 times 3 equals. There it is. Okay? So we're asked to sketch this. We good? Okay. We're asked to sketch this. So when you look at that, you need to know what it is. So can you tell by looking at that what it is? It's a quadratic. And how do we sketch quadratics? There's a whole set of steps. So first thing, does it open up or down? It opens up. It opens up because A is 2, which is positive, right? Okay. So we know it opens up. What's the next thing?
Find the vertex.
Vertex. Okay, so vertex, you find the h first, which is negative b divided by 2 times a. What is negative b for us? It'll be positive 8, right? So because b is negative 8, you're doing negative 8 is positive 8. And then 2 times a is 2. So 2 times 2 is 4, so you should just get 2 there, 8 divided by 4. What do you do with that answer? Plug it into the function. So 2 times 2 squared minus 8 times 2 plus 3. We should get 4, 8, 8, negative 8, 8, negative 5. So this is going to be our vertex, which is the highest or lowest point on the graph. That point is the highest or lowest? It's the lowest because it opens up, right? Okay, what was the step we did after this? Quick sketch. So quick sketch, my vertex is to the right 2, down 5. So it's down here somewhere. And the parabola opens upward, so we know we have 2 X intercepts. So now we need to go find them. Okay, so to find the X intercepts, we set the function equal to 0. And now to solve that, you're either going to try to factor or you're going to use a quadratic formula. And I believe here it's not going to factor. So you have to use a quadratic formula. So the quadratic formula tells you you're going to do x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. I'll give you that formula, right? So for us, negative b is 8 plus or minus the square root. B squared is 64 minus 4 times a, which is 2, times c, which is 3, all over 2 times 2. Sorry, I know I'm going fast, but this is a review, so. And just, you want to be real careful with your signs over here, right? So what is that going to be? 64 minus 24, which is 40. So this is going to be 8 plus or minus the square root of 40 over 4. And this is where you get on your calculator and you figure out what the square root of 40 is, right? 6.32.
I got 3.58.
Square root of 40?
Oh, not the square root of 40.
Oh, you mean as a final?
Yeah.
Okay, yeah, I'm going to do 8 plus or minus, square root of 40 is 6.32, and then over 4. And then you do two different answers here. 8 plus the 6.32.
It's 3.858.
Oh, yeah, 3.58. And what?
0.415.
415. You got the same thing?
Yeah.
Yep, okay. So these are our two x-intercepts. Any questions on this, sir? You asked about this, right?
Yeah.
So are you okay?
Yeah.
Yep, okay. So now we got two x-intercepts. What's next?
Plug it into the
Y-intercept. Y-intercept. And the y-intercept is just going to be c, which is 3. So now we draw our picture. Okay, so up or down, vertex, quick sketch, x-intercepts, y-intercepts, final picture. Start with the vertex. Label it 2, -5. Let's put the x-intercepts at 0.415 is about halfway, 0.5-ish, about there. And then 3 point something, 2, 3, 4, 3.58, somewhere around there. The y-intercept is 3. We draw a U, right? Good enough. Yes. Uh-huh.
So like the b on the inside, it wouldn't be negative and under the square root?
Oh, okay. You mean this part right here, the 64? Is that what you're talking about?
Yeah.
It's because it's b squared. So you're doing -8 times -8, which gives you positive 64.
Oh, okay. So
Right?
Okay, so
So that b squared will never be negative, ever, ever, ever.
oh, okay.
No matter what b is, it'll always be a positive number. And that front corner right here will always be a positive. Okay? The time you have to pay attention to it is this one right here, because it's negative b. Since it was already negative, it'll become positive. So just be careful with that. Good? Good, Jameson? Okay.
Oh, sir,
Yes.
the second one is not 0.15, it's actually 0.42.
0.42. Well, 415 is okay. We can do that. Yeah. You just round it to 0.42. All right. Anything else?
Yeah, can you help me with number 6?
Number 6. A new car is normally $21,600, but today and today only, it's 15% off. If you buy the car today and sales tax is 8.25%, how much will you pay for the car? Okay, so what we need to do here is first find out how much the car costs with the 15% off. All right? So with 15% off, the way we're going to do this is we're going to take the price of the car and we're going to multiply it times a number. But we're going to use 0.85. Because 0.85 is really saying what's 85% of this number, which is the same as 85% of that number is the same as how much it would be if you took 15% off, right? So if it was 20% off, you put 0.8 here. 30% off, you put 0.7, right? Okay, so you do that, and I don't know what you get. 18,360.
Yes.
Okay, so now that's the new sticker price of the car. Now you have to pay tax on that, right? So this is where you can use this formula. The total equals the price plus the price times the tax rate. So your total will be the price of the car plus the price of the car times the tax. What's the tax? Yep, 0.0825. So remember, that's your 8.25% converted to a decimal. Have to get a decimal there. So you do this multiplication first, multiply these together, then add that, and you should be there. 1,782?
Yeah, for the tax.
1,782, and probably some change there, right? Decimals, but. Okay, and then add those up, what do you get?
142.
$142? Close enough, okay?
I have a question.
Yes.
Well, never mind.
You sure?
Well, yeah, because I didn't know if I put the tax first, the price, and then the tax first, or the price, and then.
You're only
price.
taxed on the amount that you're going to pay for the car. So the amount you're going to pay is 15% off. You don't do the tax on the original amount.
Okay.
Yeah. You have to find the new price first, then the tax on, yeah, it's cheaper that way. I got to tell y'all this story. The other day, what was it? On my daughter's birthday, I went to H-E-B to get balloons for her, but it was like almost midnight, so the balloon place wasn't open. So I just went over to the little balloon area and grabbed a balloon and got the helium tank and filled it up myself, and I made like 3 balloons, right? And I went up to the register, and the girl looks up at it, and she's like, "Is there a sticker for that, to ring it up?" I'm like, "No." And she said, "They're $1.25 each." And I said, "Okay, fine, whatever." So she sits there and looks at me for a little while, and then she breaks her phone out, and I'm trying to figure out what she's doing. I thought she was trying to look up like the SKU or something for a balloon. Nope. You know what she did on her phone? $1.25 plus $1.25 plus $1.25 to get $3.75, so that she knew what to put into the computer. She couldn't add $1.25 3 times. Am I out of my mind to think that a cashier should know what $1.25 3 times is?
Doing it for them. They just get used to the machines type.
I know that still though.
No, yeah, you're right.
Yeah,
it's
I mean,
fast.
yeah, I know a lot of people break out their calculators because they don't, but really, would it be crazy if it was $1?
I would have laughed.
Right? You know what I'm saying? Like $1, I had 3 $1 balloons. If they broke out the calculator, would that blow your mind? Or I think $1.25 is, I don't know.
Yeah, 25, 75
No.
plus 370.
I don't know. You're a cashier, right? You should have some sense. Yes, I'm sorry.
I just got a different answer than
No, I
You got different answers?
Yeah, I got 19.
Okay, let's see here. Okay, what about this, 1782?
That's not.
That's not right? Well, why didn't y'all say something? You're gonna let the ship go down here? All right, well, let's check it. All right, let's see here. We're doing 18,360 times 0.0825 is $1,514.70. Okay. Now add that to 18,360, 19,874.7. So did you see what went wrong with yours? You're just going to have to type it back in, just make sure. Just be careful on the test, take your time. Okay, what else?
So for number 10, it's just a quadratic formula, right?
Yep,
Okay, just making sure.
yep.
For the final, like, we'll have all like the formulas.
Well, I will give you the quadratic formula. I will give you the simple interest formulas, the two of them, and I'll give you the exponential decay half-life thing. Other than that, there's nothing else. Now, if you want to make your own sheet, cost you 5 points, you can, you know, you'll have to decide if you want that or not. All right.
So what you do is minus that 15% and times the
All right, well. Oh, 13. I'm sorry. What, 13? Yes. So 13, you're asked to sketch a rational function. So this is where I think maybe the cheat sheet might be helpful, you know, unless you're going to, you know, unless you're one of those people who can remember all these steps. Okay, I'm going to go pretty quick through this, all right? This is a rational function, right? Rational function. First step for rational functions, I believe, oh, I forgot to plug in. I believe I told you for the first step to find the X Intercepts, all right? So what are the X Intercepts? How do we find those? Set the numerator equal to 0. So if you set that numerator, equal to 0, you'll have a quadratic, right? So the X-intercepts here, you set the numerator equal to 0, and then you try and solve that. So that's a quadratic. It's missing the X term, right? It's missing the X term. So there's actually two ways to go about this. Did anyone do this one yet? How did you do that? So you did a GCF. So if you pull a 3 out, you'll be left with x squared minus 16. Okay, and then from there, did you notice x squared minus 16 is x plus and minus 4? Okay, so this is a difference of squares, becomes 3x plus 4, x minus 4 equals 0, and you get two answers only. 4 and negative 4. Why not the 3? It doesn't have an x, so this 3 is gone. That's one way to do it. Another way you could have done this is this. Move the 48 to the other side. Divide both sides by 3. Take the square root on both sides. And remember when you do the square root that you have to have plus or minus. There's two options on how to solve that. You have two x-intercepts, 4 and negative 4. Next step, vertical asymptotes. Set the denominator equal to 0. 13. Another quadratic. So you can use a quadratic formula here, or you can factor. This one actually factors. Does it? Wait.
Yes.
It does. It's x.
Negative 14.
Is it supposed to be minus 14 here?
Yes.
Oh, I wrote it down wrong?
Yeah.
Okay, I wrote it down wrong. I apologize. Yeah, because plus 14, that wouldn't factor, so that would have been trouble. So make sure you fix that, make it a minus there, minus there. So it should be x minus 7x plus 2. But either way you do it, quadratic formula or factoring, you should get two answers, 7 and negative 2. All right, next step. The horizontal asymptotes. So what's the degree of the numerator? Degree of denominator. And they're the same, right? They're equal? And that was case what? Case C. And in case C, you get y equals what? The leading coefficient of the first one divided by the leading coefficient of of the top one divided by the leading coefficient of the bottom one. So 3 over 1, which is 3. Remember, you only do that in case C, when they're both equal powers. That's when you go look at those numbers. All right, at this point, I think we can sketch, right? So we can start sketching. We can start putting all the information down. So we have our x, our y. Okay, we have x-intercepts at 4 and -4. Oh, sorry, I just messed up. Those are x-intercepts, right? I just accidentally put vertical asymptotes. 4 and -4. We have x-intercepts. We have vertical asymptotes at 7 and -2. And we have a horizontal asymptote at 3. And remember what I said about the horizontal one, only draw it out at the ends. I'm going to go off camera here a little bit. And then what do you need at this point? What do you need to do now? Test points. Okay, so test points come next. So somebody give me the test point to the furthest left that we can use. -5 will work. Okay. You need -3, something in between these. Where else? Something between here and here, right? So anything between here and here.
Okay, so it doesn't matter.
It doesn't matter.
Okay.
So 0, how about that?
Yeah.
0 is a good test point. Something between 4 and 7. 5 or 6. I'll do 5. Are we done?
No.
One more test point out here. Maybe 8. And all those get plugged into the original function. So this is the time-consuming part. Are there any questions on what I've done there? Okay.
So as long as you just put the test points between, like if there's a vertical asymptote, you put one.
Yep. If you ever have 2 verticals, you want something between them. If you have 2 x-intercepts, something between them. If you have a vertical and an x-intercept, you want something between them. Okay? And then on the ends, you want one on each side. Okay? Now, we plug those in, right? So we have to do f of -5, f of -3, f of 0, f of 5, f of 8. And we should get, if you do this, I won't go through the work, you should get a positive number, negative number, positive number, negative number, positive number. So is it okay if I just put what they are, or do I need to go through any of these computations? That's okay? So -5, you get a positive number, which means you put a dot anywhere above. Doesn't matter. You can go above that dotted line or below. I don't care where you go. I'm just going to put it right there. At -3, you're negative, so down. At 0, you're positive. I'll just put it here. That doesn't matter again where it goes. And then at 5, you're down, and at 8, you're up. And then you have to connect the dots. So what has to happen to my graph to the left? Does it go that way?
Okay.
Got to flatten out to my horizontal. And then once I do that, I'll sneeze. I'm going to come through connect, connect, and down. So make it look something like that. Now between here and here, I'm going to just connect these dots together. Remember, the vertical is going to send me up here, and then this one over here is going to send me down. Just like that, like that. And then on this side, to the left, I have to go up, and then to the right, I have to flatten out. Like that. So if you get all of your information correct, right? Let's say you get all your information, but your picture is just, you can't get it drawn correctly. I mean, you'll be getting like 8 out of 10 points for that. It's not like it'll be completely wrong if you can't get the picture right, all right? Okay.
For number 17, you would solve it the way we just solved that last half-life.
Yes, so for number 17, you would solve it the way we just did our last problem, except I did not give you the half-life of carbon-14. I would provide that. I didn't put it here. I think when I did this review, I was thinking I would put the formula up there for you, but I will give you the half-life of carbon-14.
But for now, though, if we're doing the review, we can use the one.
Yep, because that's always, carbon-14 half-life is always 5,760 years or whatever it was. Yeah. Just remember, change that 3% to a decimal, 0.03, yeah. Okay, well, I will see you all on Wednesday. Get it done. Yes, ma'am. Perhaps.